Okay, that's kind of an ominous start there for that to pop up. Anyway, U1 practice test, intro to counting. So what I'm going to do is I'm going to whip through this real quickly. I will not put a lot of stuff into the calculator, so I'll leave stuff in kind of expanded form, and then I'm going to let you guys put stuff in the calculator just a lot easier. Okay, so let's go through this. We're going to find the n, which is the cardinality. Remember that cardinality or size of x, u, y. Now realize that's not the letter u. That's this. Okay, like, well, that looks like the letter U, but union intersection. Okay, so n, u, y, what's in x and or y? So all of this. Okay, so add up all those numbers: 11 plus 4 plus 8 plus 1 plus 9 plus 2. That goes there. What is in? How many things are in this? That is. The pen's going crazy. That is the complement of y, which means not in y. So all of this is in y. So what's not in y? Everything else. Okay, so all of this stuff here, 11 and 4 and 3, that's not in y, so you add those up. Okay, what's in x? All of this. Okay, so let me just show you here. In green, add up 11 plus 8 plus 4 plus 1. And here's another one, shade in the union of x and y. There's x and y. So the union is everything. Sorry, I was doing intersection. So shade in the union, it looks something like that. Okie dokie. Let's keep going. Oh, sorry. Use proper notation to show what this should be there. The area with the 11 represents. So let's clean this up to figure out where the 11 is. So I saw a couple nice answers for this. One would be, so the 11 is here. So let's talk about what 11 is. 11 is in x, but not in anything else. Okay. So it's in x. It's the union maybe of x and what's not in everything else. So it would be the union of x and what is not in everything else would be this. That's one way to write it. Okay. Another way to write it is, so it's just in x, right? So it's in x and it's not in y and it's not in z. That's another way to write it. So let me see if this is right. The union of what's not in y and not in z and x. So what's not in y is all of this here. What's not in z is all of this here. Actually, you just write that, right? The union. So it's all of this here. So we'd have the 4, the 8, and the 11. And I want, no, that's not right. So that's not good. It would be the intersection of x and what's not in y, what's not in z. Okay, so lots of ways to write this. Okay, so that's one way to do it. That's another way to do it, and there's probably other ways. So we'll take up a few more in class. Use the fundamental accounting principle. Really easy. If there are 5 meats, 8 breads, and 10 toppings, all you're going to do is multiply. That's it. Okay, so multiply those out. Tell me an answer. Next up, we're talking about these sets here: A, B, C, D, A, B, and A, F. What's the cardinality of Z? How many things are in Z? There's Z, 2 things, 2 things. What is in X or Z? Okay, the union of X and Z. What's in X or Z? Now, alphabetical order doesn't really matter, even though it would be nice. So I'm just going to write out everything X, A, B, C, D. And what else is in Z? Well, the A is there, and I'm missing the F. So all of these would have commas. Don't need a comma at the end. Set notation. What's in X and Z? So what's the intersection of X and Z? So look at these two. What is in both? Well, this is smaller, so what's in both? A is in both, F is not in both. So the answer here would just be A. What's in X or Y and Z? Oh, that's good. I think I have a typo there. That's fine. X or Y and Z. So what's in X or Y? So I'll just do that first. A, B, C, D. And everything's already repeated. So that's kind of a useless thing here. So what's X and Z? So this actually turns out to be the exact same thing. Just A. Okay. So what's in X or Y and Z? If there was something else here, the only way this would change is, let's say Y was A and F. Then what you would do is what's in X or Y, what's in the union of X and Y would include the F. And then you would say what's in this, and it would be the A and the F. Okay, so that's that question. Okay, let's switch colors. I'm getting sick of green. Expand and evaluate. I'll expand, you evaluate. Expand 7 times 6 times 5 and keep going. Okay, and then put that in the calculator. This is supposed to be a lowercase 16p4. So 16p4 is 16 factorial over 16 subtract 4 factorial. Okay, you don't necessarily need that step, but you do need this step, and then evaluate this. Okay, on a calculator. This one here, you can't do on a calculator. That's the whole point. You would go 88 over 88 minus 3 is 85 factorial. And what that turns out to be is 88 times 87 times 86, and then that's times 85 factorial, which cancels out with this. So just put this in a calculator and figure out what that is. Okay, make a true diagram represent all the different types of cards if they come in red, orange, white, 2-door, or 4-door, and may or may not be tinted. So you can just do that. You got this sort of thing. Now let me just add a twist to this. Let's say that I had this here. Let's say that every so I'm going to just change this slightly. Red, orange, and white are my cars, and then I'm going to say that they can be 2-door or 4-door, 2-door or 4-door, 2-door or 4-door. But let's just say it said that every single white car is a 4-door. Then you would just draw a branch like this, okay? And then from there, if we're tinted or not, you would go tinted. And I'll probably ask you something like this. So tinted or not, what you're going to do is put something like that, T or not T. Okay, you don't need to define everything. You just got to make sense of it. I have to make sense of it, and then you work your way through it like this. Okay, how many ways can you roll dice? Less than or equal to 6. So what you're going to do, just be careful with that. Totals less than or equal to 6. That's the totals that are 2, the totals that are 3, 4, 5, and 6. It does include 6. And if you remember, this can be done 1 way, 2 ways, 3 ways, 4 ways, 5 ways. The question I'll ask you will probably be a little smaller, but you do need to know how to even create the table for the dice, or use it at least. Okay, so you would just add those up. Roll a number that is even or divisible by 9. So what you're going to do is go ahead and figure out how many different ways you can get a 2, a 4, a 6, an 8, a 10, or a 12. Okay, so go ahead and count all those here. And then divisible by 9, well, what totals are divisible by 9? Just 9. So you find out how many different ways you can roll a 9, and then you just add these up. There's no overlap here because 9 is not even. Okay, if there was overlap, you would have to make sure you didn't double count. I think we did a question like that for homework. Okay, so find those out, figure out what those are, and add them together. Let's go to number 7. These are good questions. 1, 2, 3, 4, 5. A, B. So it's password. You can't repeat a digit or letter. So you have five numbers, 2 letters in that order. You can't repeat a digit or a letter. So just if you go numbers, you would have 10 options for the first one, 9, then 8, then 7, then 6. Okay, and then for letters, it would be 26 and 25. Okay, so another way to write that would be in order. So 10, P5, you're choosing 2 numbers. You're choosing 5 numbers and lining them up. And also 26, P2. Okay, that's when you can't repeat. So that's the same as that. You can repeat. So that's 10 times 10 times 10. So you can do this 10 times 10 times 10 times 10 times 10, which is 10 to the 5 if you want to write it that way. 26 times 26. No repetition, and all passwords must start with a 4. So if you start with a 4 and you can't repeat, then you have this situation where you have letter, letter, number, 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 and then letter, letter. So let's do the numbers first. If you can't repeat, you ask yourself how many different digits can go here. There are 9 different digits. Also remember this, guys. The digits between 0 and 9 inclusive, there are 10 of them, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So if you're confused about, if you say there's only 9 digits to choose from, that's wrong. It's 10. So if after you choose the 4, you have 9 options for the second. Okay, so the 4 is already in there. You have 9 options here. So you have 1 option for the first number, 9 for the second, 8, 7, and 6. Okay, so 9, 8, 7, 6. The 4 is already gone. And then for the letters, it's just times 26 and 25 again. Oops, 26 and 25. So that's this one. No repetition, and all passwords must end in a vowel. So let's deal with the restriction first. We're going to end with a vowel. 1, 2, 3, 4, 5 different vowels. Again, Y doesn't count as a vowel for our class, at least. So let's start at the back. There are 5 options for that. So what's that mean? There are 25 options for the next letter. Remember, if you can't repeat, you take a vowel out, you're left with 25 letters. After that, and then this one was just 10, 9, 8, 7, or 6, sorry, and 6, which is 10, choose 5, or 10, P5. Okay, so 10 times 9 times 8 times 7 times 6, that gets you the numbers just like over here, and the difference is choose this guy first, okay, choose the last number first. It has to be a vowel, and then what's left over is not a vowel. Sorry, it can be anything, so there's 26 options for that. No repetition, all passwords must contain a 9. So this is a great question. I'm not going to do this, and tell you the truth, this is a big question here. But you can ask yourself this. I'm not going to do all the work here. But there are going to be, the 9 can be in 5 different places. It can be here, 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 or here. So let's just pretend it's here. Okay, so if we put it here, then after that you're going to have 9 options, 8 options, 7 options, 6 options. Okay, for everything else, and then it's going to be 26 and 25 for the letters. Okay, but then you have to ask yourself, what happens if the 9 goes here, the 9 goes here, if the 9 goes here, the 9 goes here. So there are 5. So you're going to get a number here, and there are 5 different ways you can get this total. It's where the 9 is first, or the 9 is second, or the 9 is third, or the 9 is fourth, or the 9 is fifth. So you can add these up to 5 times, or you can just say, look, there are 5 different ways to place the 9, and then after that I have 9, 8, 7, 6. So there are 2 different ways to do that question. Okay, so the answer is 5 times 9 times 8 times 7 times 6 times 26 times 25, or 9 times 8 times 7 times 6 times 26 times 25 plus itself plus itself plus itself plus itself plus itself. Okay, so same thing. You do it 5 times, you add it to itself, or not. 7 friends are going on a trip and they sit on a plane. So the plane, there's gonna be a window that comes up, and then there are 7 friends. Oh, that's good. And then a window. So they all sit in a row. There are no restrictions, 7 factorial. Fred sits at a window. Okay, you got to choose which window Fred's going to sit at. So there's 2 options for that. So where does Fred go, at the front or the back? And after that, you have to line up the next 6 people. That's a bracket, so multiply. Okay, 2 times 6 factorial, or 6 factorial plus 6 factorial. Okay, you can say Fred goes first, 6 factorial was for everyone else, plus Fred sits on the left, or Fred sits on the right. Either way, it's the same thing. Fred sits in seat D. So A, B, C, D. Fred's going to sit here. If Fred is there, so there goes Freddy boy right there. Well, there's 6 other people, and we just put them in any order. Okay, so this spot's gone, and that would have been in seat A, any spot. Once Fred's gone, he has to be there. Then you have the other 6 people. You have to line them up, and no matter what happens, Fred's got to be here. Fred sits beside Mike. Okay, we've done this one also. So we're going to consider them as a giant person, but before we do that, we're going to figure out, is it Fred Mike or Mike Fred? So there's 2 ways to line them up. So we can go Fred or Mike or Fred, and then after that, they are now considered a big person, FM, and FM is now a giant person that has to sit together, and there's 6 factorials now to line up the 5 other humans and the giant Fred Mike person. Okay, or you can say this. Let's figure out where Fred is first. It goes Fred on the left. If Fred's on the left, then we have 6 factorial ways to line everyone up, and then if Fred is on the right, so Fred left, and we go Fred on the right, we can also do this, and there's 6 factorial ways, and you add them together. So 6 factorial plus 6 factorial, or 2 times 6 factorial. Okay, I know I'm whipping through this, but I want to get this in. Fred doesn't sit near Mike, so there's 7 factorials where they sit together, and there's also, this answer is where they do sit together. Sorry, there are 7 factorial ways in total for them to seat these people. Now what we're going to do is figure out the total, and we're going to subtract where they do sit together. So basically you're taking A and you're subtracting D. We do it that way, okay? So total number of ways, subtract where they do sit together is going to be the answer for this. So figure out that. Only 3 people get on the plane. So what I'm saying here is you're choosing from the 7, you're going to seat 3, so it's 7P3. And if the seats were in a circle, can't happen. But if it did happen, don't forget you subtract 1 from the 7. So let's keep going before we run out of time. 7, 8 p.m. You're going to watch 2 different shows, 11 shows to choose from. There are no restrictions, so you're going to go 11P3 for this. You watch Happy Days first. If you do watch Happy Days first, that means after that you have 10 choices or 10 shows to choose from, and you can put them in 2 spots, the 8 o'clock and the 9 o'clock. You watch Happy Days once, so you can either watch them first, or you can watch them second, or you can watch them third. Each time you do that, you have 10P2 options for that. So there are 3 of those, or you can add, so 3 times that, or you can say 10P2 plus 10P2 plus 10P2. So there are 3 different scenarios where you watch first, second, or third. If you watch Happy Days, you also watch Friends. I'll take that up in class. I don't like the wording of that question. Using the digits 6, 7, 8, 9, and 0. So 5 digits without repeating. How many 4-digit numbers can be formed? So here, the one thing you want to be careful with, though, I won't ask you a question like this on the test, but the answer kind of is P 5, 4, but you got to be careful here because you can't start with a 0. So you don't want to start with a 0. So the first, if you're doing it this way, just by choosing here, I'm running out of time, but here, the first number can be 6, 7, 8, or 9, and then after that, it can be, so let's say I choose 6, then I have 4 different numbers for here, times 4, times 3, times 2, times 1, okay, because you can't start with a 0, okay, a little bit tricky. How many odd numbers can you make? 4-digit odd numbers? Sorry, that goes like that. odd numbers. So you can do the same thing here, but you're going to be stuck here at the end.